Back in 2018, a single paper from Google AI landed like a meteor, and it completely changed the entire landscape of artificial intelligence. It was the paper that taught computers not just to read words, but to actually understand context in a way that had never, ever been done before. So today, we're doing a deep dive into the paper that gave the world BERT. You ever wonder how your phone's search engine or your autocorrect or even your digital assistant seems to just get what you're trying to say? The nuance, the meaning behind the words. Well, a huge part of the answer goes right back to the fundamental shift in thinking that was introduced in this very paper. Okay, so to really get why BERT was such a revolution, we have to rewind the clock a little. Before 2018, the world of natural language processing, or NLP, had a major limitation. It was basically a one-way street. Models back then, even really powerful ones like the very first OpenAI GPT, read text just like we do, from left to right. But the catch was, each word could only get its context from the words that came before it. Think about a sentence like, "The man walked to the bank to deposit his check." Without seeing the word check at the end, a model might get confused and think bank means a riverbank. Their understanding was just fundamentally incomplete. And this created a huge problem. These unidirectional models were kind of like trying to understand a really complex idea with one eye closed. Yeah, you're getting some information, but you're totally missing the depth, the full picture. The big goal, the holy grail, was to give AI both eyes, to let it see the entire sentence all at once. And that's exactly what this paper did. It introduced a brand new model called BERT, and its secret weapon was true bidirectionality. This wasn't just an improvement, it was a total game changer. You know, the name really says it all. Bidirectional encoder representations from transformers. And the key word there is, of course, bidirectional. It was built on the transformer architecture, which was the real breakthrough that made it possible for a model to pay attention to every single word in a sentence at the same time. For the first time, a model could be trained by looking at the whole sentence, left and right context, all at once. The authors themselves, they didn't pull any punches. They stated the problem very clearly. They saw that this one-way street was a massive bottleneck, a hard limit on how smart these AI models could ever get. And that was the problem they were determined to solve. So how'd they do it? I mean, how do you train a model to look in both directions at the same time without it just cheating and looking at the answer? Well, the solution was in two incredibly clever, yet pretty simple, little training games. The first big idea was this genius little trick. You can think of it as a really high-tech game of fill in the blanks. The model would be given a sentence, something like, "Paris is the mask of France," but with one of the words hidden or masked. Now, in order to correctly guess that the masked word is capital, the model has no choice but to use the context from both sides. It has to look at the word Paris before the blank and the word France after it. And this process, which they called the masked language model, or MLM, is the secret sauce. It's the thing that forces the model to develop a really deep, two-way understanding of how language works. It's not just predicting the next word in a sequence anymore. It's learning the relationships between all the words. So that first task, MLM, taught BERT all about words. The second task, called next sentence prediction, taught it about how sentences relate to each other. It was basically a game where the model was shown two sentences and had to guess, hey, does sentence B actually come right after sentence A in the real world? This gave it a much higher level logical understanding of language. And all this led to an incredibly powerful and efficient news strategy. The authors would pre-train one gigantic general-purpose model on a ton of text using those two games. And then that one powerful model could be very quickly fine-tuned for all sorts of different specific jobs, like answering questions or figuring out if a movie review is positive or negative. This pre-train and fine-tune idea is what really kicked off the explosion of specialized AI models that we see everywhere today. So, the theory was elegant. The ideas were clever. But the results? Well, the results are what truly shook the entire AI world to its core. 11. Right out of the gate, BERT set new state-of-the-art records on 11 different NLP tasks. This wasn't some small incremental step forward. It was a complete and total domination. Just look at the GLUE benchmark. You can think of it as a sort of academic decathlon for language models. The previous best score from OpenAI's GPT was a 72.8. BERT didn't just beat it it blew it away with a score of 80.5. A nearly 8-point jump on a benchmark like this it's just staggering. That's the kind of leap forward you might see once in a decade. And the authors themselves really summed up the magic of their work perfectly. The core idea is conceptually simple, right? Just fill in the blank. But the results were empirically powerful. It's that perfect mix of an elegant idea and just jaw-dropping results. The shockwaves from this paper didn't just stop in 2018, not even close. Its influence, its DNA, is baked into the AI that we all use every single day. This timeline really puts it into perspective. You can see these key moments, but BERT is that massive inflection point. It's the moment that deep, two-way understanding became the new gold standard, and it's what paved the road for the massive generative AI boom we're living through right now. And you can feel this legacy every day. The ideas that BERT pioneered are the reason your Google searches are so much smarter, why Siri and Alexa can understand more complex questions, and why the very foundation was built for today's large language models to even be possible. So, this paper really solved the challenge of contextual understanding in such a profound way. And it leaves us with this huge question. If context was the big mountain to climb in the 2010s, what's the next great barrier for AI to overcome on its journey to true understanding? It's an exciting thing to think about, for sure. But of course, as we look into the future of AI and all the incredible research happening, just remember that this has all been for entertainment purposes only.